Sketch the following graph using the slope and y-intercept method. So the first thing I'm going to look at is the equation y equals 3x minus 2. And I'd like to compare that to the slope-intercept form. Y equals mx plus b. So I look at my equation, y equals 3x minus 2, and I'm able to identify what the slope is. So I'll name the slope, which is 3. And I'll also name the y-intercept. So that is also looking at b equals negative 2. Now, one thing that will be helpful for you whenever you are naming the slope for yourself, it's really helpful to write the slope as a fraction. So I'll notice that if I have a whole number, I can always put the whole number over 1. So the slope is 3 over run. So if I'm going to calculate the rise over run, I can now point out with the slope that the numerator is positive, which tells me to go up 3 units, and the denominator is positive as well, which will tell me to go right 1 unit. So the first thing we want to do if we are starting to sketch the graph, we will begin at the y-intercept. And remember, the y-intercept is where the line crosses the y-axis. So if we're looking at b equals negative 2, our y-intercept will be plotted 0, negative 2. And from that y-intercept, we'll use the slope to get to the next point on the line. So how that works is we will use the rise over run, starting from our y-intercept. So we're going to go up 3 units and right 1 unit to get the next point on our line. So if you want to notice, I always kind of draw the slope triangle to help me see this. I went up 3 units and right 1 unit to get to the next point on the line. And since slope is consistent, what happens is you can keep traveling from the point you just drew using the slope to get to the next point on the line. So you could also go up 3 units and right 1 and draw the next point, and up 3 units and right 1 again to draw the next unit. And we can still draw these points as far as we can if we need to. Also keep in mind that you could also start at the other way. So if you're looking at your y-intercept again, remember that your slope is positive, so it could also mean positive over positive or negative over negative. So if we're going to get to the next point on the line, if we go the other way, you might notice that you can go down 3 units and left 1, and you'll see you'll get a point that has the same distance away. So really, when you're using the slope and y-intercept, you only need a few points from your y-intercept and a straight edge to connect your line. I plotted a few more so you can see the constant change, rise over run. And if you're going to complete this graph, we need to make sure we connect our points with a straight edge so that we have our line. Sketch the following graph using the slope and y-intercept method. Y equals negative 1/4 x plus 7. So a slightly different example from the last. Again, you will notice that the equation is in slope-intercept form. y equals mx plus b. And the first thing you will want to name would be who is the slope. And I'll look at this as the slope is -1/4. And here I see that with the slope, the negative sign is in the middle of the fraction bar. And one of the hints that the book has been telling you so far is that it might be nicer to replace the negative sign or put the negative sign in the numerator. So I'll do that. So basically the opposite of 1/4, -1/4 is the same thing as saying -1/4. So when I look at the slope, when it's time for me to get to the next point on the line, I'll be looking at it a little more carefully, and I'll be traveling 1 unit down and 4 units to the right. So we also will want to name our y-intercept. So we'll notice that the b, if we look at our equation, b is actually +7. So now we're ready to graph. And we always begin at our y-intercept. So the y-intercept is where the graph crosses the y-axis. And when the y-intercept is 7, that means we have 7 units from the origin. We go 7 units up. So we're going to plot our point right there. And now we're going to use the slope, starting at our y-intercept, to get to the next point on the line. And I'll follow the directions of my rise over run. So if the slope is -1 over +4, I'll be going down 1 unit and right 4 units to get to the next point on the line. So if I want to draw that, going down 1 unit and right 4 units. I'll use the slope triangle to remind myself what I just did. So I went down 1 unit and right 4 units. Now we have 2 points that the line should be going through, and technically we can connect them for our line, but I like to be positive, so I like to always try to go a little bit further. So I'll start from the next point that we just created, and again go down 1 unit and 4 units to the right. So we should have our next point on the line right about here. And to show the consistency, again we went down 1 and 4 to the right. And a lot of times I can often use the other way, starting from the y-intercept as well. So if we remember that our slope was -1/4, where we put the negative sign in the numerator, that also means the same thing as having the negative sign in the denominator, but that gives us a different set of directions. So that would imply to us, if we're looking at it in this form, that we are going up 1 and left 4 from our previous point that we plotted. So if I were looking at my y-intercept one more time, which was 7, if I go up 1 and left 4, I can get a point on the line. Sometimes it's nice to complete it. And I can keep doing that if I need to, up 1 and left 4. So just to show that, we go up 1 and left 4. We can see our next point on the line, and we can keep going. Up 1 and left 4. And like I said in the last example, you don't really need that many points. But sometimes it's nice, especially if you don't have a straight edge, you can actually connect it a little bit straighter when you draw your line. So the last thing we have to do is connect our points that we plotted the best that we can. So we have our line, And I always like to extend my line through the edges of the axes.